Ok, hola. Ok. Hola, ¿cómo están hoy? Deja buscar el... Ok, ¿se puede ver todo esto? Creo que sí. Ok. Soy Ángel Rivera y sí, hablo español, pero no lo hablo tan bien que puedo darle una charla entera. So, esta noche voy a hablar aquí en español y después voy a cambiar al inglés para la charla. Y primero quiero darle muchas gracias al equipo de DevOps Days Bogotá. Hicieron tremendo trabajo aquí poniendo este evento a presentar nosotros y ya, hicieron mucho trabajo. So, darle un round de aplausos para el equipo de DevOps Days Bogotá. Ok, so voy a cambiar a inglés ahora. O creo que. Ok. Esta es la agenda para la charla mía. Voy a hablar de Kubernetes bien rápido y después de los skill sets que la gente necesita o pueden aprender para hacerse, ¿sabe? Para entender el Kubernetes mejor. Después voy a hablar de Docker. Ok, ahora voy a cambiar a inglés. So, my name is Angel Rivera. I'm a developer advocate for Circle CI. And if you want to reach out to me after this talk, please do so on Twitter is the best way. So yeah, just that real quick. Before we start, I speak to a lot of developers and people in DevOps. And when they're first starting out with Kubernetes, they don't really understand the word or the acronym K8s. So I just wanted to let everyone know I'm going to be using K8s in my presentation quite a bit. So I just wanted to share that K8s basically stands for Kubernetes, and the number 8 represents the characters between the K and the S in the word Kubernetes. So it's just very simple. The 8 represents all those characters between the K and the S in Kubernetes. Great. So now we got that out of the way. Let's go ahead and talk about why Kubernetes. Why would someone use Kubernetes? A lot of times I hear, oh, well, my boss told me to use it, or, I'm a techno junkie and I like to go ahead and play with different technologies, and those are all valid reasons. But I wanted to share the common reasons why people actually would use Kubernetes. So if you are a software development team or operations team or DevOps team, and you want to increase the velocity of your software development cycles, definitely implement tooling and practices, right, that help you do that. And that's what we're here, right? We're learning about DevOps. We're learning how to get things done faster, in a more efficient manner, in a more optimized way. And of course, when you're talking about increasing velocity or efficiency or optimizing, you're going to need automation. And Kubernetes is one of those tools that can help you with that process. So again, if you're trying to, increase your velocity, efficiency, optimizing, your software releases or your development life cycles, definitely look at Kubernetes as a platform. A lot of other benefits that you can get is helping to save some money. So what I mean by that is Kubernetes is a pretty complex but very robust platform. And what Kubernetes can bring to the table as far as cost cutting is it manages all your resources really, really well. So you can basically squeeze a lot more efficiencies or performance out of machines. If you implement Kubernetes, it knows how to manage those resources really, really well. That leads into another reason why is you can basically help with having your applications be more available, right? So with Kubernetes, it gives you that opportunity to add more systems to your cluster, right? And it enables you to perform things like elasticity, or scalability that gives you elasticity. So if you have a high availability requirement, Kubernetes helps with that. by being able to deploy multiple instances of your application and ensuring that they're healthy and available. And then also when you have like low performance or low demand on that application, it could also scale down, right? Which helps again with the cost cutting and also performance. So high availability, elasticity or scalability is a great reason to implement Kubernetes for your services and applications. So what I wanted to do is jump into a really quick introduction into Kubernetes for folks who are not like Kubernetes savvy. So the first thing is a definition. And yeah, you know, you can read this definition, it has all the buzzwords, right? But what I want you to focus in on is that Kubernetes is an open source container orchestration system. And that's basically, you know, the crux of Kubernetes. It's managing your applications that are built into containers or images, right? And a lot of folks just kind of, I don't know why, but glance over that and don't really focus in. So again, please focus in on that portion because this is really important if you're just starting out with Kubernetes and trying to understand what it is. It's a container orchestration system, and that's it. Without containers, all Kubernetes would be is just a Kubernetes system running and you know operating under its own services. So again, focus in on the container orchestration system aspect of Kubernetes. So real quick, before we started with Kubernetes, I like to go back a little bit into history. So if you look at the traditional deployments, this is when we were having our applications running on like a single operating system, a single server, bare metal, and then you had a couple instances of your application running. That was great, but until you needed like to increase your demand, or if you got increased demand, you had to basically scale up, right? And if you had to do that, you had to literally put more physical servers, like bare metal servers. So you can, as you can imagine, it's very expensive. It's very inefficient, and yeah, it's just really, it was terrible all the way around. But it was the only thing we had at the time. And if you fast forward a couple years, then came the advent of the hypervisor, right? And that, if you can see in the middle there, between the application and the hardware and the operating system, it sits this hypervisor, which was just software that knew how to basically communicate with the underlying operating system and hardware. And then also you were able to package up your application into what we call a virtual machine. And all that was another kind of wrapper for your application, but it included operating system, another kernel, right, that you had to manage, and then you could build out more instances of your application within that virtual machine, which is great. Like I said, the hypervisor just knows how to manage those resources underlying between the application, virtual machine application, and then the underlying operating system and hardware. But you fast forward to today, where now you know, we have container deployments, and you look at that container runtime, which is equivalent to Docker, right? You now have similar kind of, I would say, a schema or mechanism as the hypervisor, but the container runtime is a lot more lightweight. So instead of having that hypervisor in a virtual machine with all those kernels, now you have a way to package your application with using basically the single kernel, right? And the container runtime knows again how to talk to the operating system and the underlying hardware, as well as the application running in the container. So it's super lightweight. You can squeeze a lot more performance out of those systems, and yeah, just a great way to kind of run your application now. So let's talk about Kubernetes, and I'm going to just decompose that a little bit. And what I mean by that is just kind of touch on the critical components to Kubernetes. So I'm sure you've heard that Kubernetes is a cluster. And if you don't know what a cluster is, it's basically an amalgamation or a grouping of machines that are working together to provide a service or an application, right? So it's nothing more than that. And if you look at the diagram to the right, you have the Kubernetes control plane. So if you look at those boxes, the one to the right is, if you envision it as a server, it would be one server as the control plane. And that basically hosts all of the Kubernetes services on it. Well, most of the Kubernetes services. I usually like to refer to the control plane as as the brains of Kubernetes, right? It's actually, this is Kubernetes. If you look to the right, then you have the smaller Kubernetes nodes, which are, again, servers, right? But they are just basically what we call worker nodes, which I'll get into in a minute. And that's where all of your containers live. That's where all of your applications live and do, basically it's the workhorse of the cluster. So, right, we're talking about control plane. They're also known as primary nodes, right? Again, that's where Kubernetes lives. It's the brains of the cluster. And here's another kind of diagram. Again, right, I just wanted to show some of the services running. So Kubernetes is built on a bunch of services. And as you can see, right, on the left side, which is the primary node or the control plane, you have the Kube API server, you have the scheduler, you have the control manager. And if you look to the right, you have the worker nodes, right? And if you notice, there's a difference between the primary node and the worker nodes. And the biggest difference is the container runtime is on all of the worker nodes, right? So that means this is where your applications live. They're running in containers, right? And there's also some Kubernetes services, right, that are needed, like kubeproxy for networking, and yeah. So that gives you kind of an idea of what the hierarchy or the structure looks like in Kubernetes. And this is a 4-node cluster, so that means there's 4 servers running in this diagram. And again, right, the worker nodes are there for, to provide basically the horsepower for your Kubernetes cluster. One of the things that I wanted to talk about was pods, which is, I would say, the lowest kind of object within Kubernetes, but it's also the most important object in Kubernetes, right? And the pods are basically a grouping of containers. So if you have an application or a couple applications running in your Kubernetes clusters, they would be considered, grouped into pods. So just have that in mind when we're talking about Kubernetes in the future. And finally, the most important I would say element of Kubernetes is the container runtime, which is what I'm going to get into in a little bit here. But again, right, just a quick breakdown of the critical elements of Kubernetes. So I speak to a lot of developers, and some of them have a hard time, right, learning Kubernetes because it's like I said, it's a complex system. It's very robust, and it has so many layers and of like just services, right? There's a lot going on there. So I just wanted to share some skill sets that I think that people should learn, or at least, have some understanding. And yeah, so that they can have an easier time with Kubernetes as they start learning and playing with it or working with it. So the first thing is, if you're not familiar with continuous integration or continuous delivery practices or DevOps practices, I would definitely look into that and get yourself some experience, at least a knowledgeable foundation about what those things are, how they work. Believe me, I speak with a lot of developers, a lot of people in the technology industry, and this is still I would say like a learning curve, right? Folks are still not fully implemented yet or adopting these practices. But if you decide to go down that road, these are the kind of benefits that you would gain, right? Some insights into securing things. And by the way, you're automating these as well. So you can test automatedly, building, deploying, right? All that stuff that goes along with continuous integration, continuous delivery, and DevOps. Another skill I always recommend people understand, especially developers, is security, right? And more specifically, roles-based access controls, because that's kind of like the schema within Kubernetes. And if you're going to, run Kubernetes in production, you definitely want to have a foundational knowledge of how the security policy is implemented in Kubernetes. So role-based access controls, understand that. But I think as developers and operations folks, we can serve ourselves and benefit from knowing a little bit more than just roles-based access controls. We should be learning a lot more about security and understanding, the implications of deploying our applications like that. So another skill set is networking. I don't expect anyone to become a network engineer or guru, but understanding some of the fundamentals like domain name services, it's very important because, in Kubernetes, you're standing up applications, especially if you're doing web type applications, that traffic has to be routed, right? You need to understand how it's being routed within Kubernetes. So having a foundational knowledge of networking and all those fundamentals will help to, alleviate some of the pain points that people have, especially starting out with Kubernetes. Monitoring, logging. As developers, we're used to logging, but I don't think we're so used to monitoring, right? So definitely understand the difference between the two, and also some of the tooling and mechanisms that Kubernetes uses to monitor, the pods and applications running and services running within the platform. It's really important to understand this because when you start having issues, and I promise you will, if you're working with Kubernetes, you will have issues in some way, shape, or form with your applications or with the cluster itself. Monitoring, logging is definitely going to save you. So storage, right? There's a couple different ways that Kubernetes kind of attaches to persistent layers. This is more for like elastic block storage. So if you're using Amazon or any kind of Google Cloud, there's going to be ways for you to connect data, to save data, and just understanding the basic concepts of persistence within Kubernetes will help you. Obviously APIs, right? We're developers, we're used to this, but I just wanted to mention that Kubernetes kind of was built on an API first paradigm. So understanding, how those Kubernetes cluster or the Kubernetes APIs, work and how you interact with them is really important. YAML. If you're not familiar with YAML, definitely get in there and start learning a little bit about what YAML is. I'm here to tell you it's not a programming language, so please get that out of your heads. It's definitely not that, but YAML is a data store, but it's heavily used within Kubernetes. So understanding, again, right, the foundational concepts of YAML and how it's basically a data structure will help you along the way as well with your Kubernetes. Infrastructure as code, really, really important here. I have to tell you, if you're working as a developer or an operator, whatever it is that you're doing, jump on this. Understand infrastructure as code, because not only will it help you with your Kubernetes job or infrastructure, it'll also help you. This is a skill set that will help throughout, right, IT or in technology, period. So definitely invest some time in learning infrastructure as code. Start leveraging that so you can start building your Kubernetes clusters using code instead of going into the AWS GUI or the GCP GUI and building your infrastructure that way. That's not going to help you in the long run, right? So the final skill is definitely understand containers, right? Have a deep knowledge of containers. And what I'm talking about here is Docker for the most part. So let's talk about what is Docker, right? Basically, it's a way to package your application and run it in whatever target system that supports Docker. It's just that simple. You can read this definition. I don't want to get in too deep into it because it's just basically that. It's a way to package up your application and run it in target environments that support Docker runtime, like Kubernetes. So let's do a little bit about decomposition of Docker. So the way that Docker I mentioned the Docker runtime or container runtime. Docker engine is the same word, right? Or it means the same thing. It's the container runtime or Docker runtime. And here's a quick diagram, right? If you look at this diagram, the things I want you to kind of look at primarily are the blocks around the edges, which is the Docker API and the Docker CLI. The Docker API is a way you interact with the runtime using or the way you interact with the runtime programmatically, right? So that's how Kubernetes is attaching to the Docker runtime that it hosts and conducts transactions or executes things on it. The other blue box, the Docker CLI, is the way you would manually do it. So manually interact with the runtime. This is more leading towards when you're installing it locally on your machine and you're building images locally or you're running containers locally as a developer. So, understand the two differences there. And then plugins, of course, is how you extend the Docker engine. And this is where you can write some code that, if there's some functionality in the engine that doesn't come stock, you can write some plugins to then extend that engine to make it do whatever you want it to do. And as developers, I've seen some slick extensions and plugins to the Docker engine. So what I want to talk about now are there's two, what I consider the most important elements of Docker is the images and containers. So if you don't know what a Docker image is, basically it's a template for your container, right? So I mentioned earlier that, you package up your application into a container, and that's basic, into a Docker image, and then you run it as a container. So I like to use the expression of a cookie cutter. So, if you had some dough laid out in front of you, you take that cookie cutter and you smash it down and you make a cookie. That's like the cookie cutter is the image, the Docker image, and the cookie you just made is a spawn of that cookie cutter. So that's your container, right? So think of it that way, right? Like just smashing down this Docker image and making a cookie, and that's your container running. And if you make multiples of them, they should all look the same. I'm a terrible baker, so my cookies are pretty shitty, but even with a template. But that's my kind of explanation on that. I hope that makes sense. So if you're going to build an image, right, with the Docker CLI is how you would normally do it. Well, that's the way I do it. And basically, you would use the Docker build command, right? So what that looks like is when you run the Docker build command, you have to supply a Docker file. And a Docker file is basically your blueprint, right? This is the actual, I would call it the cookie cutter template. And this is what a Docker file looks like, right? Really simple. It's almost YAML-esque, right? It has that kind of YAML feel. And I believe it's probably based off of YAML. But anyway, this is what it looks like to build a Docker image. So if you can see, if you have a node application, if you look where it says, you have your copy package JSON file, that just basically introduces or copies the package information, your dependencies, into your container, and then you're running, right, executing npm install. So that'll just do whatever npm install does on your machine, but inside of your container. So that's how you're building and packaging your application into a container. And finally, you have some lines there, right, that expose 5000, as I mentioned earlier, networking. You have to open up a port for your container to, receive ingress traffic. And then finally, the command there, npm start, obviously, right, it's going to start the application. So here's a quick list of Docker image commands, the most important ones that you must know and understand how they work, right? If you're going to play with Docker or use Docker. I just wanted to list a few of the things, that you should focus in on when you're working with Docker. And then you can get more fancy, right, later on when you understand these things. So let's talk about containers. I already explained to you, right, that you're spawning containers based off of an image. So let's see, how do you get a container running, right? The Docker run command is exactly what you need to use to create containers. And then when you create containers, here's a list of things, right? So when you create a container, it's just an instance of your application running. So you could have that same image spawn 10 different instances of the application, and they'll be running all in a different process, right? And that's where, remember when I said about pods? That's where pods kind of come into play, where they, if you have 10 different instances of that same application, that would create basically a pod. So it's like a wrapper around all those 10 apps. But here's the main commands that you need to learn and understand when you're working with containers. So that, if you look at the top one there, PS is just basically looking for processes. So that means, are there any containers running? And then this also has the Docker start and stop. So once you do the Docker run command to create a container, if you have a container that's a daemon or persistent, then you can just start and stop those containers using these commands, right? So you don't have to kill them and erase the work that you've done. I would personally not use static containers. I would do Docker run every time, because this is Kubernetes designed to be more of an immutable system, and that's what you want, right? You want to just have that thing running. And in Kubernetes, Docker containers die all the time on their own. Maybe they run out of memory, or there's some CPU issues, or whatever reason. For whatever reason, they will go down. And that's what Kubernetes does, is brings them back to life, right? So respawns a new one. So it's almost like, it's basically a respawning tool in some cases for containers. Let's do a quick recap on images, right? Again, here's the commands for the images, just get to know these commands for images. Also, the containers, definitely understand what those are and how to run them, how to maintain them, how to stop them. And you can also look at logs, right? So whenever you have issues, again, remember I talked about monitoring, understanding the way Docker logs things is important. And here's the list again of the skill sets that I mentioned. Hopefully everybody has some sort of knowledge in some of this stuff. If you don't, just go ahead and, get to learning, or reach out to me. I'll try to help you as best I can understand what's going on. Here's some resources for developers. There's a lot of things. I use the micro K8s lately as a developer when I'm building out containers and applications for my Kubernetes clusters. But there's tons of resources out there. This is just a small list that I wanted to share with everyone. Y that's it. So muchas gracias a todos por escuchar esta charla. Y si se quieren conectar conmigo en el Twitter, @punkdata es mejor. Gracias.
Muchas gracias por tu presentación, Ángel. Vamos a continuar finalmente con los sorteos del día de hoy, guiada por Rafael Martínez, organizador del DevOps Days Bogotá.